Hello, welcome back to Blender Sushi Live Noding. In this episode, I'll be showing you the breakdown of how I created this starfish. So this starfish is procedurally generated. It's actually quite interesting, and it might be kind of everything. It's basically like a series of like a broken dream or a series of broken creations. There's this shader, procedural shaders that's generating the random color. And also, like, I actually use the shader to make the difference between the top and the bottom part of this starfish. The starfish itself, it's not 100% perfect, but it's kind of, it has all the ideas of procedural creations. We have a scattered cone on this starfish, and we also have sphere chalk to generate just these basic shapes of starfish. Currently we have this 5-sided starfish, but I can make it like maybe 8. But you can see suddenly it's kind of broken, and the starfish itself needs a little bit of value here in the radius in order to work. And if I want this to work, I need to add a skin data. Yeah, and now we have our starfish back, now with 8 legs or tentacles. Starfish like this is really quite interesting. The way I generate this, starting with sphere chalk, I started with just simply using line, where this line is being duplicated like radially using circle, this circle, then using the matrix normal, and then just multiply the two, and you get this kind of like a star. Let me show you. Sometimes it goes weird. If I, okay, just let's make this 5 again. So we have like a star. Again, we need to reset the skin data in the Skin Modifier. You might also notice that I'm using Skin Modifier, and there's all kind of things. I could add armature, but instead I don't worry about that for now. Just take a look back into sphere chalk. So line multiple by circle, we have like a starfish, and then it's being merged by the distance. And then I subdivide it a couple of times, and then I use noise displace. I could reduce the number of cut. And we also have the kind of like a motion driven by noise over here. The noise is driven by time and being offset. And the output in this case is just Polygon Edge. So often, like when in Blender, you're what's the most powerful object in Blender is actually, I think it's actually grease pencil. If we can convert grease pencil into curve or mesh, then the rest of them, you know, I think become the like a whole procedural things. Currently we don't have a way to convert grease pencil into curve, so curve and mesh, they too are really powerful. When we later be able to convert grease pencil into like a volume SDF, then it's gonna be, I think, the most powerful tools. I mean, combined together, you know, like with particles, etc. For now, it's outputting this mesh viewer. Of course, it's gonna output like a Polygon Edge. From the Polygon Edge, I'm using Skin Modifier to generate this kind of like skin mesh. And from here, I can actually create armature, right? And we can control the skin using armature. I'm not gonna do that, it's gonna mess up everything. Instead, we have back to what we had before. Let's go back. So Polygon Edge output goes into Skin Modifier. Now we have our starfish have skin. I know it's not perfect, but the whole idea is there. And the skin, with the skin we can use geometry nodes to scatter all these little cones. Some starfish have the cones on the top or just the bottom of the starfish, but this one have the top and the bottom. So that's one thing. You can use geometry nodes to separate the top and the bottom part of the starfish maybe, and then you just scatter the cone at the bottom. Right now I have the starfish kind of scattering points randomly, or using Poisson disc actually. So we have all these little cones on this starfish. Like I said, it's not perfect. It's because it's Skin Modifier doing something in the background. Ideally, maybe we could use curve, you know, like use curve like that, and then turn the curve into volume. Make sure the curve also have like a radius, and join them at the center like that. And from the volume and the radius control, you can then generate the mesh, and you can scatter. And then you need to bake the model, because at the moment this thing is changing every frame. You don't want that. You want like a bake geometry, and then you skin it using armature, and then you control the bone armature using curve. You can actually do that using Spherechalk. I tried it in the past. So let's back to starfish. We have cone that's being scattered. Okay, this cone can be randomized, can have different radius. The point distribution, actually you can just instance it on the point itself. But if you're doing it this way, the normal is disappearing. So just use point distribute. That's fine. I'm using this transform. This one is multiplied by 3, and then this one is divided by 3. If I didn't do that, the surface might be too small for our scattering. That's why I multiply this by a number, and then subdivide this by another number. So I have more area. I think there's another way to do that. And then I simply assign the material on this object. And the material itself is a shader, as usual. It's a basic shader. One of them is using Voronoi for the bump and for some variations of colors. I have two materials for the cones and for the other material. It's just a random per island. Per instance, it's gonna get a different color. Let me try to, if I disconnect it, we have only a single color. But since I make it random per island for the hue, if I can reduce the hue or just actually increase it, we have random color. Maybe try to be subtle a little bit. And this should render correctly when you're using cycles. If you use it in Eevee, it's less less complicated. It's yeah, we get a starfish. What could be better maybe here, if we, like I said, if we are able to control the radius of these creatures based on the skin modifier, that's one way to make this better. For the tentacles, I'm gonna show you a little setup. Okay, this is the tentacles that can be animated. And let me show you. So it's basically like a line that's being displaced by the noise. The line have 10 points, and the output is this curve geometry that can be transferred into geometry nodes. And here we have a scale control of how big the noise we are using for each point of this line. So this is one way to make the tentacles better, because the output, in this case, the output is a curve object. So yeah, if we actually use range number, because this is in SphereChop, we can kind of make and generate multiple objects. So if we have like 25 different objects, and they should be animating differently. So like I said, this is like, there's a lot of things going on, but a series of different node tree that you can combine together to create the starfish. I think the starfish is really pretty cool. So we have all these lines that we can scatter into something. Icosphere, assign the scaling, save this very quickly. Okay, we should put this inside the collections. So maybe move this into a new collections, call it blah. Can't think of another name. And then with this icosphere geometry nodes, we can distribute some points and then instance some geometry from collections, turn off whole collections, blah. There you go. This is some kind of crazy looking starfish. I mean, it's not completely perfect, but still, this is the idea. There we go. Can bring in the original object. If we can have like 100 variations, for example. Maybe doing it this way, 100 variations of the tentacles. So now our brain cannot tell if they are repeating or not. Also, we can make it smoother. Polyline viewer actually have lots of options underneath this one. Make this 20 or 8. We can control the shapes and the speed. Yeah, I think that's not bad. Alright, so that's basically what it is. It's based on the starfish. In the future, I will try actually with sapling and geometry nodes, and let's see if the radius can transfer into geometry nodes to be used inside the volume. I think it should work. These control points need to have a value or radius that we transfers into geometry nodes. But anyway, I'll think about that some other time. Alright, so thanks again for tuning in, and I'll see you next time. Thank you. Bye.